Okay, 9:30. So I know I do have at least one question over the homework. What was it? Okay. What? Oh, it did? Improper's fine. So what did you get? What was your answer? Was this on number 51? Yeah, 45 also. So that's fine. Yep. The question is if you get like negative 13 over 4 as an answer, do you have to convert it to a mixed number? And so the answer is no. Just leave it like that. That's fine. Yeah, that's fine. I sound sick. I don't think I'm sick. I think it's just allergies. So I don't think I'm getting anyone sick, all right? What else? Anything else on that one? On the homework? No? 40. Okay, number 49? Okay. So number 49 was h of x equals absolute value, x plus 13. And you're asking about the second one, which was h of negative 13, right? And then I'll do the third one in a second. So for this one, you replace x with negative 13, right? So negative 13 plus 13, absolute value. Negative 13 plus 13 is 0, right?
That's my problem.
Yeah. Oh, okay. Got you. You treat the absolute value like a parenthesis, so you do everything in it first. So do the negative 13, 13 get 0, and then the absolute value of 0 is just 0. And then the next one was negative 14, right? So again, you'll do the negative 14 plus 13 first, which is negative 1, but it's inside absolute value, so the absolute value of negative 1 is 1. Yeah, just remember you do what's inside. Do it all first if you can. I mean, sometimes we can't do everything if there's a variable in there or something. Okay, 51. Okay, so 51, the function was defined h of x is 5 minus 2x squared. And you want the second one, h of 3/4? Okay. All right, so the fractions, of course, something we don't really care for too much, right? So let's just replace, again, all of our x's with 3/4 and see what we get. So 5, take away 2, and then 3/4 squared. Now, technically, that 3/4 is in parentheses. It's the only thing being squared. The 2 out front, or you could say the negative 2 out front, is actually multiplication, and it's waiting waiting a little bit after the squaring. It'll actually multiply. So what is 3/4 squared? 9/16. So that's 3/4 times 3/4. You multiply straight across, and you get 9/16. So we have 5 minus 2 times 9/16. And multiplying 2 and 9/16 together, or negative 2, however you want to do it. Let me just do these two together. What would that be? It's 2 over 1 times 9 over 16. Well, you can cancel here, reduce. Yes, you can cancel. That's okay. If you cancel, you'll get a 2. 2 will become a 1, and 16 will become an 8, so it'll be 9 over 8. Or you multiply straight across, go 18 over 16, which reduces to be 9 over 8. right? Because 2 goes into each of those. So 9/8 right there. So what we have now is equals 5 minus 9/8. And that's 5 is a fraction, 5 over 1 minus 9 over 8. The only way you can add or subtract fractions is if you have a common denominator, right? So I need an 8 down here. So I multiply top and bottom by 8. 5 times 8 is 40 over 8 minus 9 over 8. And then 31 over 8. Yep, and the book goes a little further. They do it a mixed number, but you can just leave it like that. Okay. See, we had a lot of absences last time, and I talked about some stuff from last time. If you weren't here last time, you should probably watch that video of what you missed. I have your exams. You can get those at the end of class. I'll pass around the sign-in sheet. So let me start this over here. And we are going to start a new section today. I'm going to try and get through 2 sections today. It just depends on how you do with this. We're going to jump to chapter 5, 5.3. This is on page 355. Can you all see that up there? This is intro to what are called polynomial functions. And in this section, we're going to be looking at adding and subtracting these things called polynomials. So there's a lot of language in this section, a lot of, not definitions, but things that when I say them from here on out, you need to know kind of what I'm talking about. We're gonna talk about what a polynomial is, but before we get to even polynomial, we need to get some other things established. Okay, so let me just write some things down here. If I write the number 4, right? The number 4 is just the number 4, right? There's nothing really complicated about that, right? Compare that to, let's say, 4x. That's a little different, right? That means 4 times something. We don't know what that something is, right? X. Or I could write something like 4xy, and now we have the 4 and an x and a y, and they're all being multiplied, right? Or I could do something like 4x squared y. So that means 4 then times an x, but x squared means x again, right? That's like a 4 times an x times a y. So things are starting to get more complicated. But all of these things, all 4 of these, are referred to as terms. Okay, terms. Terms, I'll put a little quote around that, terms. Terms are basically expressions that have numbers and letters, but the operation between those is all multiplication. So when I write 4x up here, it's implied, even though I don't put the multiplication symbol there, it means 4 times x, right? And when I put 4xy, that means 4 times x times y. And then the last one is 4 times x squared times y. So it's implied that there's multiplication. So anytime you have letters and numbers mixed together with multiplication between them, we call that individually, each one of those is a term. Got it? Now with the term, we have something called the coefficient. The coefficient of the term is the number that's in front. So what is the number in front of this first term? 4. What's the number in front of the second one? 4, 4, 4. So all 4 of those terms have the same coefficient. The coefficient is 4. Now let me give you another example underneath here. How about this one? Negative x squared y z. First of all, is that a term? Yes, it's a term. We got letters basically mixed up, but they're multiplying between them. What's the number in front of everything? Negative 1. Okay, so we have to visualize that negative as being a negative 1. Therefore, the coefficient is negative 1. Okay? That's what a term is. That's what the coefficient of a term is. Just identify the number, and you're in business. Is that okay? Okay. Now what we want to do is we want to talk about, let me kind of put a little line in front of it. That's what coefficient of terms. That's what a term is. Let me now put the next sort of definition here or idea, like terms. And the book goes through more detail than I'm going through as far as explaining it, but sometimes the book's definitions can be confusing when you read them. Yeah, so I just try and simplify it for you, okay? Like terms. Think about like terms as terms that are similar in some way, right? So, you know, an analogy would be if you have like a room full of animals, right? You've got maybe a couple of cats and you got a couple of dogs and, you know, different sorts of animals. You kind of group them together by what they are. And with terms, we like to do that also. We like to group things together as long as they are like. And to be like, they have to have certain similarities. Okay, so here's what it would mean to be a like term. Like terms have same variables. Now, when I mean variable, or when I write variables, what do I mean? Letters, okay, same letters, comma, raised to exactly the same powers. That's what it would mean to be a like term. You have to have the same exact variables in there, and the powers on the variables have to be exactly the same also. Notice that to be a like term, I've said nothing about the coefficient, right? I've said nothing about the number out front, just the letters. Agreed? Okay. So let's see if you can, I'm going to make like I'm going to do a comparison, some examples. I'm going to give you two terms. You can tell me whether or not they're like or not. Okay, so how about this one? How about negative 3xy, comma, the next one I want you to compare it to 5xy. Are those the same? Are they like terms? Yes, because they both have x's and y's, and the powers on each of them, the x has a 1, right? X has a 1, y has a 1, y has a 1. So these are like terms. So we're good. How about this? Negative 3x squared y 4, I'll do 4 instead, 4xy squared. Okay, so do they have the same variables? They both have x's and y's, right? Are the variables raised to the exact same powers? No, because look, the x has a squared on it. What does the x over here have on it? A 1, right? I meant to say right here, this is bad, right? In other words, that makes it so that it's not like terms. And the y also, right? The y doesn't match up. The y on the first one has a 1, and then the other one has a 2. So no go here, right? So no. No, yes, up here. How about x squared y z and negative x squared y, and that's it. Well, they both have x squared, they both have y, but this one doesn't have z, and this one does. So no. They have to have all the variables, they have to match. If it has a z in it, the other one has to have a z in it also. Yes. Exactly the same. Yes. Yep. Well, the negative has nothing to do with this, because remember, the negative in front, right there, that's our coefficient, right? -1. What's the coefficient of this one out here? It's a 1. We don't need to write it, but it's a 1. But we totally ignore coefficients when we're checking to see if they're like terms. So you just kind of cover up the coefficient and you look at what's there. Is it exactly the same as the other one? Yes or no? In this case, no, right? It's missing the z. So no. So the reason why we need to be able to identify like terms is because what we want to be able to do here is try and add them and subtract them. And to add, we're going to discover that to add things together, terms, they have to be like terms. That's the only way you can add two terms together, is if they're like. Now, let me give you one more example here. How about 5 and 9 x to the 0? I'm trying to trick you here. Well, you might immediately look at this and go, wait a minute, this one has an x, this one doesn't even have an x, right? Yeah, what's x to the 0 though? 1, isn't it? X to the 0 is 1. So isn't that 9 actually 9 times 1, which is just 9? Now, do these look the same? Are 5 and 9 like terms? Well, I mean, you have to kind of think about this a little bit, because it's confusing if you say, well, they have to have the same variables. But they don't have variables, right? So don't overcomplicate it. Just look at it. 5 and 9, aren't those just numbers? Can't you put 5 and 9 together? I mean, like add or subtract? So whenever it's numbers, they are like terms, numbers by themselves. Where, on this x? Oh, then it wouldn't be. Then they wouldn't be like terms. This is a unique example because I put x to the 0. If it's x to the 1, it doesn't turn into a 1, right? But that x to the 0 turns into a 1. Okay, so let's get to one of the main results here. Adding like terms. To add like terms, first, make sure they're like terms. Then, just add the coefficients. Just add the coefficients up. So let's do an example underneath this. Okay, add these two together. 5x squared plus 3x squared. So you first have to realize that each one of these by themselves is a term, right? 5x squared is a term. 3x squared is a term. We are going to add the two terms together if they are like. So are they like? Well, they both have x squared, and so they match up exactly, right? If they do, if they are like terms, all you have to do is identify the coefficients, 5 and 3, which is 8, right? And so you write 8 what? X squared. You don't do anything crazy with, you don't do anything with the x squared and the x squared. You don't put those together and try and make it x to the 4th or something like that. To add like terms, all you do is add up the numbers in front. That's all. So it's kind of like if you wanted to, saying that you have 5 erasers plus 3 erasers, right? adding them, you should have how many? 8 erasers, not 8 erasers squared or something like that. I mean, again, the dogs and the cats, right? Put 5 cats, 3 cats, 8 cats. So keep the important thing is keep the x squared there. Don't change the x squared. Just change the number in front. Okay? Because in a minute we're going to be multiplying. When you multiply terms together, that's different. Then you do have to pay attention to what's going on with those exponents. All right, let's try another one. Why don't we add negative xy plus 4xy minus 7xy plus 2. Okay, so when we look at these, we have how many terms? 4 terms total, right? 1, 2, 3, 4. Notice that when you have terms, they're always separated by addition and subtraction. Remember, each term by itself just has multiplication going on in between the letters and the numbers, but between terms is addition or subtraction. So we have 4 total. How many of them are like terms? 3 of them. These 3 right here, the first 3 are like terms. All 3 have x, y. So if I want to put those together, what I'm going to do is look at their coefficients, which is what? -1, 4, and -7. So I'm going to write that over here on the side. -1, 4, and -7, right? I just wrote it on the side. I'm kind of doing this like scratch work. I want to take -1, I want to add 4, I want to subtract 7. So -1 plus 4 is 3. 3 take away 7 is -4. So you get -4 of those now, right? So I'm going to put -4 xy. Now the plus 2 I couldn't do anything with, right? I can't combine it. So just leave it there. That's it. Okay, now we need to get a little more complicated. All right, so that's what we're going to do. Don't do it. Okay, I want you to add here. I'm going to start off by putting this in parentheses. X squared minus 3x plus 3 plus 7x squared minus 5x minus 4. So one of the first things I want you to notice is that we have addition, right? We have addition sitting between 2 sets of parentheses. Inside each of the parentheses, I have some terms. So in the first parentheses, I have how many terms here? 3 terms. In the second parenthesis, I have 3 terms. Now, in the first set of parentheses, are any of these like terms in just the first set? No. In the second set? No. Okay, so I can't do anything inside those parentheses. So the only thing I can do now, hopefully, is try and get rid of the parentheses. How do you get rid of parentheses? Distribute whatever number's in front of them. So what number is in front of this parenthesis out here that's not there? A 1. And so if you distribute a 1 through, nothing changes, right? So I'm just going to rewrite. I mean, there is a 1 there. You don't need to write this step, but that's what's happening here. This becomes x squared minus 3x plus 3. And then in the second parentheses, again, there's a 1 out in front there, right? A plus 1. If that had been minus, it would be a different story, but it's a plus. Now I'm going to go 1 through here, and I should be able to drop the parentheses again. So plus, go ahead. Because it would be like a -1. So the -1 would have to distribute through the parentheses and change everything. We're going to do that. We're just not ready yet. We'll do it pretty soon here. So we've eliminated all the parentheses, and now we look at what remains. We try and identify like terms. So I'll highlight them. I have an x squared, right? Do I have any other like terms? 7x squared. Positive 7x squared, right? I have a negative 3x. And over here I have a negative 5x. And then the 3 and the 4, or negative 4 out here are like terms. So those are my like terms, color-coded. So how will you put the first two together? How do these come together? Add the coefficients, right? So add the 1 that's not written but in front here to the 7, so you get 8. 8x squared. And then you do the same thing with the green ones here. What's negative 3, and then take away 5 more, negative 8x. And then finally, 3 and negative 4 gives you negative 1. And that's it. There's nothing more you can do there. Now we're going to move right into subtraction. Oh, yeah, I haven't talked about that yet. I'm doing it a little different than the book. The book starts talking first about polynomials and degrees of polynomials and descending order, all that stuff. I kind of get right into this first, and then I'll start talking about what we call this, and you know, that's a second degree polynomial, blah blah blah. But let's get all the mechanical stuff for it down first. Okay, next, let's move on because we're going to do subtraction now, all right? So subtracting like terms. What do you think the only difference is? Yeah, I mean, it's just going to do subtracting the coefficients instead of adding. So make sure they're like, right? Make sure like terms. Then subtract coefficients. What makes the subtraction a little bit more challenging is that sometimes subtraction of integers and stuff can be a little complicated. So let's just do an example. What would negative 5x squared plus 2x plus 1, what would that in parentheses minus 4x squared plus 7 minus x be? So again, I look in the first parentheses, I don't have any like terms, right? Second parentheses, no like terms. So I need to try and get rid of these parentheses. On the first one, I can just drop the parentheses because there's really a 1 out in front of it. So it'll become negative 5x squared plus 2x plus 1. But now the important step, that's actually a negative 1 sitting in front of that second parentheses right there. That's a negative 1. So when you distribute it through, the effect it has is really it changes the signs of what's there. So we had a positive 4x squared, it's going to become a negative 4x squared. We had a positive 7 becomes a negative 7. We had a negative x becomes a positive x. Y'all follow that? Okay. Now let's put our like terms together. I'm going to go a little bit slower here on this one. Negative 5x squared minus 4x squared plus 2x plus x plus 1 minus 7. So what have I done on this next step? Yeah, just kind of moving things around putting my like terms right next to each other. So this x squared, I put them right next to each other. The 2x, the x back here, put them next to each other. The 1 and the -7, put them next to each other. And now I'm going to look at the coefficients. -5 for the first one, and then take away 4. So what's -5 take away 4? -9, okay, x squared. And then on the next one, I'll have +2, and what's the number in front here? +1, so that'll be 3x, good. So plus 3x, and then of course 1 take away 7 is -6. And that's it. Okay, I'll do some more examples in a minute, but now let's talk about some of the language that I kind of skipped from the beginning. You get the basic idea of, though, identifying like terms, putting them together, addition, subtraction? Okay. So now, here I'm going to give you 3 different definitions here. Monomial. Underneath that, binomial. Underneath that, trinomial. Three different definitions. A monomial is, mono meaning one, is a single term. As an example, if I just wrote 4x squared y, that is a single term, isn't it? And therefore it's called a monomial, one thing. A binomial, bi meaning two, of course means two terms. An example of a binomial, x plus 7. Right? X is a term, 7 is a term. Two terms. In this case, they're added together. If I did, I'll do this after this, x minus 7, that would also be a binomial. So those are, two examples. It doesn't matter if there's plus or minus between them, as long as you've got two terms. It's a binomial. And then trinomial, what do you think trinomial means? No, it's 5. No, I'm kidding. 3 terms, right? That would suck if that's what it meant. It'd be too confusing. 3 terms, right? And we do a lot with trinomials. That's an example of a trinomial. Now, as you might expect, you can go further than that, right? 4 terms, 5 terms, 6 terms. We stop having names for them after a certain point. It gets kind of ridiculous to sit there and have a name for how many terms you have. But we deal a lot in math, at least at this level up through college algebra. You spend a lot of times with the single, double, or 1 term, 2 terms, and 3 terms. But just know you can keep going, all right? So that's a little bit of language for you. If you have more, okay, in any of, well, I shouldn't do ... Let me do it this way. All of these together fall into a group of what are called polynomials. Polynomials, poly meaning what? What does poly mean? Many terms. So polynomial is a more general way of saying this. Polynomial means basically many terms. And I'm going to put here, could be 1. I guess one way of looking at it is a monomial is just 1 term, right? Binomial is 2. Trinomial is 3. And then you could have 4 and 5 and 6 and 7. All of those fall into a group, a category that we call polynomials. So a monomial is a polynomial, a binomial is a polynomial, a trinomial is a polynomial. Polynomial is just a very general term. It just means that you've got terms. And you may have 1, you may have 2, you may have 3, you may have 100. All of those are called polynomials. Now, there are some other restrictions on polynomials that, again, the book gets into, but I don't want to complicate the issue. I'll just state it. To be a polynomial, you have to have your variables have to be raised to integer powers. Like you have to have x to the 0 or x to the 1 or x to the 2 or x to the 3 or x to the 4. You can't have like x to the -5. If you do that, it's no longer a polynomial. But I'm not going to test you on that. Everything you're going to see is going to be written the way it's supposed to be written. But later on, when you get into college algebra, you'll be studying things that are not polynomials. And so just realize that there's ways to have terms together and it not be a polynomial. No, I don't think so. Now, we also have what's called the degree of the polynomial. Okay, so I'm going to put that under here. The degree of a polynomial is the highest power of any single variable in a term. I should say in any term. Let's say in any term instead of a term. Any term. So let's look back up at those three examples I gave you, the monomial, the binomial, and the trinomial. These are all polynomials, right? For that first one, 4x squared y, what is the degree of that monomial? It's the highest power of any single variable in any term. Well, it only has one term, right? The highest power that I see on any single variable is 2. So the degree of that would be 2. All right? Now, we usually use n for the degree. So I'm going to say next to this, n is 2. And below here where I have polynomial degree, I'm going to put n here so you know what I'm talking about. Degree of the polynomial is n, so n up there is 2. What's the degree of the binomial? The binomials here, both of these. What's the highest power? 1. And that's because the x's have power 1 on them, don't they? So n would be 1 there. And then what would the degree of the last one be? 2. Again, because the x squared right here, 2. So n is 2. All right, let's try something now. I'm going to just give you something to add up. It's going to be a little more difficult, as you'll see. Let's try this. Example. I want us to do parentheses. 3/5. Yes, I did that. X cubed minus 2/3 x plus 1/2 plus 1/2 x cubed minus 4/9 x minus 2/5. Well, I'm going to help you through this one. You'll have time on your homework. So we have 2 sets of parentheses, right? And inside the first set of parentheses, are any of these like terms? No. Second set of parentheses? No. So let's try and drop parentheses. Can we just drop them? Yes, because it's a plus between them. Just drop. So this equals 3/5 x cubed minus 2/3 x plus 1/2 plus 1/2 x cubed minus 4/9 x minus 2/5. So all I did was drop the parentheses there. And now I will identify like terms. I have an x cubed and an x cubed, right? X to the 3rd power. if I want to put those two together, I have to add up their coefficients. The coefficients of those are what? 3/5 and 1/2. So I'm going to do that on the side. I have to do 3/5 plus 1/2, which means I have to get a common denominator. Hmm. 10. 10 is a common denominator. So what we do is we try and figure out how we can turn the 5 into a 10. How can we turn 5 into 10? Multiply 2, right? So we multiply top and bottom here by 2. What do we get? 6 over 10. Plus, now on the 1/2, I have to turn the bottom into 2, so I multiply it by 5. So I have to do the top by 5 and the bottom by 5. So 1 times 5 would be 5. I'm sorry? Or 5/10, yes. Now that we have the same denominator, we can add straight across. 11 over 10. And then, so that's just, this over here was just me doing my scratch work on the side, right? I'm doing this 1/2 and 3/5 added together. I know when I add those, I get 11/10. So 11/10 is the new coefficient in front of 3x squared. I mean, x cubed. Yeah. I got you. Okay, let's do the next one. The next like term I have is x, right? In front of the first x, I have a negative 2/3. Don't forget about that negative sign there. And in front of the other one, negative 4/9. So I have the pleasure now of putting those two together. Lucky me, right? So I'll do it right here. Yeah, happy Valentine's Day. Negative 2/3. I'm going to write it as negative 2 over positive 3. Remember, with negatives in front of fractions, it can be on the top or the bottom. That negative, I'm going to put it up on the top. Negative 2 over 3. And on the other one, I'm going to have minus 4 over 9, like that. Everyone understand where I'm getting these from? Okay, now we need common denominator on this one also. 9. That's good because one of them already has 9, right? So 9 here, I'd have to multiply top and bottom by what? 3. 3 on top, 3 on bottom. So 3 times the negative 2 on top would give me negative 6 over the 3 on the bottom, of course, gives me 9. And then 4 over 9. So now that they have the same denominator, I do, how do I do that? It's negative 6, right? Take away 4. Negative 10. Negative 10 over 9. Yes. I don't know. Oh, it's in the problem right here, right? Like, well, this one, the one on the left, I had to make, the LCD is a 9. So I need to turn this into a 9. So I multiply, forget this is here. I multiply top and bottom here by 3. Negative 2 times 3 gives me negative 6. 3 times 3 gives me 9. Over here, this one already had 9, so I didn't have to touch it. I just bring it straight down. No? What I'm doing is I'm taking this right here, okay, just that, negative 2 over 3, and I am saying I want to multiply that by a 1. Now, the one that I choose to multiply it by is a very clever choice of 1. I multiply it by 3 over 3, which is 1. Right? Multiplying straight across, I get negative 6 over 9. Right? Like this. Okay. No, don't apologize. You got it, though? Okay. Flip, what, this one right here? No. No. No, because that's what we got when we went across top. We got -10, and on the bottom we got 9. I mean, we don't do anything with the 9. We don't add them, but we just, that's our fraction. We just leave it. So that's the coefficient in front of x, right? So I go back up here, -10/9 x. And then the last like terms we have are +1/2 and -2/5. So I get to put those together. I'll do that right over here. I'm going to do, what was it? +1/2, so 1/2 -2/5. What's my common denominator between these two? 10. So on 1/2, to get a 10 down here, I have to multiply top and bottom of it by 5. Right? So 5/10 minus, and then on the other one, to get a 10 on the bottom, I have to multiply top and bottom here by 2. So I get 4/10. And now you go and do your 5, take away the 4, which is 1/10. 1/10. So we get +1/10 or -1/10? +1/10. That is it. We're done with that one. Be careful on these problems. When we had our last test, when we had fractions, remember when we had fractions, we cleared them out? We found LCD, we multiplied both sides of the equation by the LCD to clear out fractions. Does that ring a bell? We are not even touching that. This isn't even the same sort of problem. So you cannot clear fractions out here the way we did before because we don't even have an equation. When you go back and look at the original problem, which I put all that color and stuff on it, but the original problem has no equals. Like, it's not an equation. Right up here? It's not an equation, so you cannot multiply both sides by anything trying to get rid of fractions. So that's why we have to keep the fractions the whole time and do all this stuff on the side. Yes? Well, we'll always convert a mixed number over to an improper one. You know how to do that? Okay. So, but I'll never present you with a mixed number. Yeah. Miguel's talking about if you ever have this, you know, how would you add that to like that? Like, how do you add those two together? Well, first thing you do is you convert this one over. How do we convert this to an improper fraction? 3 times 4, which is 12, and then plus 1 is 13. So you get 13/4. And then the other one, 2 times 5 is 10 plus 4, so you get 14/5. And then you go get an LCD and you do that. But that's, I'm not going to do that to you, but that's the way it would be done. Yeah. All right. We are going to move on. Let me give you another one. This time, I'll put something in here that you really like. Decimals. All right, can I just drop the parentheses? Not on the second one, right? Because I have a minus there. But on the first one, I can. So this should become -1.4x to the 4th minus 9.2x squared minus 2.5. And then when I distribute that through, that negative sign through, it changes all the signs, right? So the 3.3 is positive, it'll become negative. The negative 6.1 is negative, it becomes positive. Negative 7.8 is negative, it becomes positive. So just switch the signs. Then get your like terms, right? Do we have like terms? Let's see. X to the fourth, x to the fourth, which means I need to put their coefficients together. So I need to take the negative 1.4 and I need to take the negative 3.3 and I need to combine them. So that means I need to do negative 1.4 and then minus 3.3, right? How do you do that? No, remember, add the coefficients. We can't. That's why I'm doing this. We cannot move decimal over because it's not an equation. So we just got to put those two numbers together. Well, they're both negative, right? So 4.7, positive or negative? Negative 4.7. Negative 4.7. Because what you're doing, I mean, it's like kind of like if I do an example underneath this, negative 2 minus 3, right? That means you're taking negative 2 and you're taking away 3 more, it gives you negative 5. Here, we have negative 1.4, we're taking away 3.3. So you're pretty much, if you want to look at it this way, you're adding 1.4 and 3.3 together, but then your answer is negative. This is all about sign numbers, right? This is all sign numbers. I guess what I'm trying to say is the most challenging part of these problems are this part, I think, right? Don't you think? This is the part that's most challenging. But these are things that hopefully you've seen enough of. If you are having problems with this still, you've got to get help from me or the tutoring lab. Because that's arithmetic of sign numbers. And it takes a long time to get good at that. I can't show you this right first time ever here in class and then all of a sudden you're an expert. You have to do repetition of those things. So I've got negative 4.7 there. Negative 4.7 what? X to the 4. Now I need to get my next like term, which is x squared, x squared. I need to put the coefficients negative 9.2 together with 6.1. So negative 9.2, and then I'm doing plus 6.1. Put those together, you get what? Negative 3.1. Okay, again, if that's one of those things that you're getting hung up on, make sure you get some help with that, okay? Because that'll cost you on the test, of course. And it was x what? Squared. And then the last one, we put together just those constants that are by themselves in the back. Those two. 5.3? Okay. Plus 5.3. That's it. It takes time. You got to relax and on this one you don't. You have to keep them as decimals the whole time. I was thinking about something while I was putting this up here. What was it, the problem before that we had all those 9s in it? Yeah, over here. I like random useless information sometimes, so I'll share some random useless information for you. Has anyone ever heard, like maybe military, when you're talking over a radio or something, that you use niner? Yep. Have you ever heard that before? Okay. I didn't know that. I know niner instead of 9. I didn't know that. I'll have to look into that. I know why 9 is niner. Do you know why 9 is niner?
Because when you are calling, for example, for a code provider,
Mm-hmm.
the receiver
Mm-hmm.
will get confused.
Okay.
The 9 transmission.
Okay. I heard that it came from this. During World War II, you know, you had the fighter pilots, you had the Germans, you had the Americans, you had the British, you had different people flying through the air using the radio. And the Americans would be talking to each other, and they'd be trying to tell someone, you know, coordinates or something. They'd be using the number 9, so they'd be talking, and the Germans would be picking up their radio transmission, and or the other way around, the Germans would be talking, and the Americans would be picking up some of it, and the German word for no is 9. So, like, if a German was trying to tell someone else, you know, one of his, you know, buddies or whatever, hey, no, no, the American might think that that's one of his buddies saying, you know, 9, like 9, you know, 9 o'clock, look 9. So they started using niner so that wouldn't get confused. Now, I don't know about the 3. I'll have to look into that. That's interesting. See, that's random useless information, right? Okay. Really? Yeah. I'm fascinated by World War II history stuff. I mean, I'm just all into that stuff. Okay. Do we want to do multiplication? Let's do this. I think I'm going to give you time. I had really considered today coming in here and giving you a quiz grade on your homework from last time. Okay? So I'd like a show of hands. How many of you would like a quiz grade today on just you showing me your homework that was supposed to be done today? Okay? Y'all look around. How many? 1, 2, 3, 4, 5. So only 5 people in here are saying that they have done their homework from last class. That's pretty much what's being said. That can happen. Okay, we talked about what adjustments can be made, how can we get better, how can we not be 11 people not passing the test, 11 people passing, how can we get there? Doing your homework is one of those ways. I mean, this shouldn't be a eureka moment for you. I mean, that has to happen. I don't like to check homework, okay? To me, this is college, okay? This isn't high school. This isn't grade school. I'm not here to take you by your hand and walk you, you know, right through this. You have to at some point take that initiative. But if I'm going to have half my students fail a test, I will check homework every day if that's what it takes. Okay? So this is your one warning, okay, that effective immediately, I could walk in here any day and say, let me see your homework. And if it doesn't look good, it's going to be a 0. And that's it. We won't even talk about it, all right? That'll be it. I expect that what I get for homework tonight will be done and completed by next class. If you have issues with it and you can't get it done or you're having trouble, then you go to the lab. Or you ask questions at the beginning of class, all right? But I want you to succeed. There's something a colleague of mine was telling me about. She was jogging. She saw this guy's shirt, and it said something like, "I can explain it. I can explain it to you," or something like, "I can explain it for you or to you, but I can't understand it for you." Right? And that's kind of like this. I can explain this to you all day long. I can tell you why we have to do that or why you multiply top. I can give you all the details, all right? But I can't understand it for you. You have to understand it yourself. And to do that, you've got to practice. So, you know, do your homework, be ready next class, come with questions, be prepared, and we go from there. So for the people who are ready today, what I'm going to do is I'm going to record 100 for you for a grade that will wind up replacing your lowest quiz. If we have a quiz and it's low, I'll replace it with your 100. Yes. Yes. I'll replace it with that one. Yes. Yeah. That's fine. I'll do that. Okay, so for your homework tonight, which you should have done by next Tuesday, will be off of page 361. 11. That's a quick one. 21 through 20. Oh wow. Oh, through 37 odd. 41, you're not going to like me for 43. And that's it. Now, for those of you who really want to, practice and stuff, anytime I give problems like this, and you finish the problems and you want to do more, you can always do the evens. I don't assign the evens because the evens are not in the back of the book. The answers aren't in the back of the book. Okay? All right. Now, I still wanted to give you a quiz today, so let's do a quiz now. All right? So everyone, those 5 are going to, this will be a quiz. You can only work on your own, okay? You cannot work with anyone. You can use your book. You can use your notes. All right? But you can't use each other today. I just want to see what you can do with some stuff that we did today. All right? So everyone has that homework. Make sure that the quiz that you're going to do right now, tear it, separate piece of paper, you're going to turn it in. Make sure you put your name. Make sure you put the date. You don't have to put quiz or anything like that, just your name and the date. And I'd like for you to do these problems right here. There we go. I'm really just seeing on the first one, can you group like terms together? Can you add coefficients? And then this next one is I want to see how comfortable you are with fractions.